So section 4.1, the inverse function. First of all, we're going to study function. We already did the function in section 2.3. I don't remember which section we did the function. We're going to do it again. And then we're going to study one-to-one function. Then we're going to do the inverse. So the function, it's a relation. What's the meaning of relation? If you remember, any order pair with x, y. Like if there exists x and y, that means this is a relation. Now, this relation is called function if each x has one and only one y. For example, each x goes to one and only one y. Let's do an example here, just to refresh your memory about the function. If you remember, each x goes to one y. This is x, this is y. Let's say 1, 2, 4, 6, 3, 5. Each x goes to one y. This x goes to the 5, 3 goes to the 6. So each x goes to one y. Each person goes to one place, which is fine. If you see two persons from here goes to one place, also is going to be fine. Like this example, x, y, 1, 2, 3, 4, 5. 1 goes to 4, 2 goes to 4, and the 3 goes to 5. So each x has one y, one and only one y. 1 has one y, 2 has one y, 3 has one y. So it's fine. Like this person goes to one place, this person goes to one place, this person goes to one place. It doesn't matter if you have two persons goes to the same place. So this one is a function. How does it look like if you find like this case is not going to be a function. If you see a person one goes to the 3 and 1 goes to 4, 2 goes to 5. You see 1, which is a person, goes to two places, 3 and 4. That's why this is not a function. Because I saw 1x goes to 2y. So this is not a function. At the same time, if you want to check this function by using horizontal line test, we already did example like this. If you have function like this, so remember we're going to graph a horizontal line test here, and we can check. So I graphed the horizontal line test. At this point, this is the x. This is the x goes to, here's the first y, and here's the second y. That means I have an x goes to two y's at the same time. So this is not function. So these cases, if you see one of these cases, it's going to be not a function. The first thing, every time we will see 1x goes to two places at the same time, to two y's, or 1x has two images, that means this is not a function. Each x goes to one y. So this is just a function. Now we're going to add one more condition. It's called not 1 minus 1, 1-to-1. 1-to-1 function. 1-to-1 function. That's how you call it. If you see when you take in college math 1414, so 1 minus 1 function, that means 1-to-1 function. That's how we're going to read it, 1-to-1 function. So it's the same thing. You see, it's exactly the same condition, the first condition here. A relation is called 1-to-1 function. 1-to-1 function if you see the first condition, exactly the same condition here. each x has one and only one y. Each x has one and only one y. But we have another condition. We have to make sure each y, in this case, each y has one and only one x. That means x goes to the x, and also we have to make sure each y goes back to only one x. So here's the thing. We have to make sure each x goes to one y, and each y here goes back to one and only one x. Each y here goes back to one and only one x. In this case, we will call this function is one-to-one function, because the first condition when each x goes to one y is going to be just a function, because it satisfies that each x goes to one y. It satisfies the condition of the function, so this is the function. Then we're going to do the second condition. We will check each y goes back to one x. If this condition is satisfied, that means the function is going to be called one-to-one function. About how to find the function is one-to-one, let's start with a simple example to make sure the function is one-to-one or no. So here's an example. They're going to give you this example, and you have to do exactly the same steps. So if you have f equal -2, -4, 1 and 4, 4 and -2, 8 and 11. So
Sir,
now yes,
I'm sorry, I can see the numbers on the screen. I can really see it.
let me. What about now?
Oh, yes, thank you.
Close the lights, I think. So now let's check how we're gonna find this is a one-to-one function or no. So the first thing, make these order pair. Make sure this is a relation, because each x there's a y, each x there's a y. So this is fine. That means this is a relation. Now, the easiest way, we're going to graph two columns. And be careful, do not repeat the number. So -2 goes to -4, -2, and here is -4, because this is the x and here is the y. So -2 goes to -4. 1 goes to the 4. This is the x, this is the y. 4 is the x here, not the same 4 here. Goes to -2. 8 goes to 11. Now we see the first condition, each x goes to one y. So the first condition is satisfied. This is the first condition. It's a function. Why? Because each x goes to one y. Each x goes to one y. Each x goes to one y. This x goes to one y. Now we're gonna satisfy the second condition. We're gonna check the second condition. Each y goes back to one x. Each y here goes back to one x. This y goes back to one x. This y goes back to one x. That means the second condition is satisfy each y goes back to one x. So it's one-to-one function. That's it for this example. So let's do another example, the same one, but we're going to do a little bit change. So here's f equal Here's the example. F is -2 and 4, 1 and 4, 4 and -2, 8 and 11. Let's check this one is one-to-one function or no. So the easiest way, again, we're going to graph two columns. Do not repeat the number. X, Y. So -2 goes to the 4. So here is -2, here is 4, -2 goes to the 4. The second one, this is the X, this is the Y, this is the X, this is the Y. So 1 goes to the 4. So I'm gonna say 1. I'm not gonna write down again 4 here because I already have 4. I'm not going to repeat the numbers. So 1 goes to the 4. The third number is 4 goes, you see 4 on this one, the X, goes to the -2. 4 goes to -2. And 8 goes to the 11. So if you check the first condition to satisfy it's a function, we will see each X goes to 1Y. The -2 goes to the 4, 1 goes to the 4, which is fine. These two persons goes to one place. 4 goes to -2, 8 goes to 11. So the first condition is satisfied that each X goes to 1Y, so it's a function. Now let's check the Y. The Y here goes back to 1X. Check the 4. The 4 goes back to 1, and the 4 goes back to -2. That means this Y goes back to 2X's. So that means the second function, the second condition is not satisfied. So it's not one-to-one function. Why? Because 4 goes back to 2X's, -2 and 1. Y goes back to 2X's. So this is not a one-to-one function because it's not satisfied the second condition.
Sir, so when it's not a function, when the X is going to 2Y's?
When okay, we will do example of like this. When X goes to 2Y's, that means the first condition is not satisfied. So it's not a function. You don't have to do the second condition. Okay, that's good question. We will do an example like this.
So for example, if 8, that is the X, and goes to 11 and 2, it's not a function?
Yes, it's not a function. So you don't have to do the second condition because we have to make sure it's a function. Then we will check if it's a one-to-one function. So if the first condition is not satisfied, that's it. You don't have to check it's one-to-one function because we have to satisfy the two conditions. Okay?
Okay.
That's good question. I will do example exactly like what he said. Now here's another example. F is -2, -4, 1, -2, 1, 4, 8, 11. Again, the easiest way is to make two columns. This is the X and another one for the Y. Now, here is X. This is X, Y, X, Y, X, Y, X, Y. Keep these in your mind. So -2 goes to -4. -2 goes to -4. 1 goes to -2. 1 goes to -2. 1, I'm not gonna repeat the 1 because I already have 1 here. I'm not gonna write down another 1. 1 goes to 4. And 8 goes to the 11. Now let's check the first condition. The first condition is a function. So -2 goes to one place, which is -4. 1 goes to -2 and 4. So 1 goes to 2 places, which is -2 and 4. That means I have 1x goes to 2 y's. So I'm just gonna say this is not a function. So if it's not function, I don't have to satisfy the second condition because the first condition is not satisfied. Even if you satisfy the second condition, but you still have something missing, which is the first condition, because the one-to-one function, you have to satisfy these two conditions. If one of these conditions is not satisfied, that means it's not a one-to-one function. That means this is not a function, so it's not one-to-one function. That's it. So always you can get example like this, make a tables and check the two conditions. If the first condition satisfied, you're gonna go to the second condition. If the second condition satisfied, that means it's a one-to-one function. If the first condition not satisfied, so it's not one-to-one function. If the first condition satisfied, but the second condition not satisfied, so you're gonna say also it's not one-to-one function. If they gave you, this is the second type of examples. If you have f of x equal x squared minus 2x. Before that, let's do the vertical line test. If you remember, we took the vertical line test to make sure it's a function. If you have function like this, let's do like this. Like this function. So if you remember, to make sure it's a function, we have to graph a vertical line test. So the first thing, the vertical line test, to check vertical line test, to check it's a function. So now if you graph any vertical line test here on this function, like I'm going to graph one here. This is the first vertical line test. And I'm gonna graph another one here. Second line test and another one here. So it's up to you how many lines you're going to graph. So check with the first one. This x goes to 1y. This x here goes to 1y. This x here goes to 1y. That means every x here, this x goes to 1y. This x here goes to 1y. And this x here goes to 1y. That means every x goes to one and only 1y. So now in this case, this is a function. This one, we're just gonna write down function. Now we're going to do another. Remember when we trying to find the function is one-to-one or no, we have two conditions. The first condition is a function when every x goes to 1y. The second condition is when every y goes back, each y goes back to 1x. So how are we going to do that when we have a graph? When you have a graph, the second condition is going to be a horizontal line test. Horizontal line test to check its one-to-one function. To check each y goes back to 1x. But make sure you have to do the first condition here, then you're going to go back and do the second condition. The first condition, if they ask you, this graph is one-to-one function, so I'm going to start graphing vertical line test to check each x goes to 1y. Then to check the function is one-to-one function, the second condition, so we're going to do a horizontal line test to make sure each y goes back to 1x. So let's graph here a horizontal. I see on this graph, we just need one horizontal line test. Here's the horizontal line test. We have to make sure each y goes back to 1x. So check here on this y. Here's the first y on the line test, the horizontal line test, and this y. This y goes to this x, so it's fine. This y goes to this x. So this one is fine, this one is fine. You have to check it in the middle. This is the first y. Each y goes back to 1x, yes. So again, when you have a graph and you need to find, it's a one-to-one function, first of all, go ahead, satisfy the first condition. How? By graphing vertical line test. I graphed 3 vertical line tests. So check here, for this x goes to 1y, here goes to 1y, this x goes to 1y, this x goes to 1y here. So that's why mean each x goes to 1y. Now to satisfy the second condition, we're going to graph a horizontal line test, and we will see each y goes back to 1x. But check out this y here. This y, like let's say this is a 3, number 3. 1, let's say here's the coordinates, the y coordinate, 1, 2, 3. So the y here is 3, the y here is 3 because it's a horizontal line test. But check the 3 here on the first y, it goes back to this x. And the 3 goes back to another x. That's why, that means it's x here and x here goes to the same y. So this y goes back to 2 x's. So that means the second condition is not satisfied. So this is not one-to-one function. Let's do another example with the graph, because I'm going to use this one. I'm going to show you how to graph it using the calculator. If you want to make sure it's going to be easier for you if they give you just a function without a graph. So now here's another example. Don't forget the coordinates. This is the function. So let's say this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so here's an example. They give you a graph. They tell you, is this a graph? Is one-to-one function or no? So let's start satisfying the first condition by using the vertical line test to satisfy it's a function or no. So let's graph a 3 vertical line test. That's going to be enough. I'm going to graph one here. You can graph more than 1, 3, more than 3. This is the first one. Let's graph here another one. And here is another one. For a 3 vertical line test. Again, it's up to you. You can graph more. So now let's check. You see this x here? This x here goes to 1y here. Go to the second one. This x here goes to 1y here. And this x here goes to 1y here. That means each x on this graph goes to 1y. This x goes to 1y. This x goes to 1y. This x goes to 1y. That means the first condition is satisfied. I can see each x on this graph goes exactly to 1y. So this graph is a function. Now to satisfy the graph is one-to-one function. Let's check it first. We're going to graph horizontal line test. Let's use another marker. Horizontal line test. Check what I'm going to do. I'm going to graph one horizontal line here. And you can tell me here's horizontal line test. Now the y here on this line goes to how many x's? Check. The first one, I'm gonna follow the line to the graph here. That means this y goes back to 1x. Check on the other side. This y, let's follow the graph here. This is the first x. Here's the first x, here's the second x. That means the same y here goes to this x on the graph. And the same y here goes back to this x also on the graph. That means y goes to 1, 2, 3 x's. So I have y goes back to 3 x's. This y goes back to 1x, 2x, 3. So I'm just gonna say this is not one-to-one function. That's it for this example. Because I told you, you can graph more than one horizontal line. Let's graph another horizontal line test here. So let's check, this is the y. Let's follow this y to the graph. Here, this is the first x. This is the y, goes back to the first x on the graph here. Keep following the graph, this is the second x. And from the other side, the graph, follow the line until to the graph, this is the third x. That means again, we found a y here goes back to 1, 2, 3 x's, which is the same thing. So again, this is not one-to-one function. So it's up to you how many lines you're going to graph. You just need one line to prove that this y goes back to more than 1x, then it's going to be not one-to-one function. Let's do this one. They're going to give you f of x equal negative 4x plus 12. So you have two options to find this example is one-to-one function or no. So the first thing, to find if it's one-to-one function, let's make a simple table here with x and y. Let's choose any points here. -2, -1, 0, 1, 2. I'm plugging these points in the graph and here in the function to get the y. So when you plug in -2 here, it's going to be -4 times -2 plus 12 is going to be 8 plus 12 is going to be 20. -1 is going to be -4 times -1 is going to be 4 plus 12 is going to be 16 plug in 0 is going to be -4 times 0 is going to be 0, plus 12 is going to be 12, and plug in 1. So -4 times 1 is going to be -4 plus 12 is going to be 8. And plug in the 2 is going to be -8, because -4 times 2 is going to be -8, plus 12 is going to be 4. So you see, each x goes to 1y, and each y goes back to 1x. So that means this is one-to-one function. So like exactly like you're doing here. You just pick any number, pick more numbers here and more numbers here. You will find x, y, -2 goes to 20. -1 goes to 16. 0 goes to 12. 1 goes to 8, and 2 goes to 4. That means each x goes to 1y, so the first condition is a function. The second condition, each y here goes back to 1x. 16 goes back to -1, 12 goes back to 0, 8 goes back to 1, 4 goes back to 2. That means this is one-to-one function. This is the first thing you have to do. The same thing, you can graph the function. You can graph the function. I'm going to show you how to graph it. We already know how to graph this one. Just plug in 2 points to get the graph, and we will do the same examples, but we will do the graphing. So you have 2 options. The first option, pick any points here, a plug in, you can get another point. That's mean you will see each y goes to 1x. Each y goes to 1x. That's mean this is going to be one-to-one function. Alpha for the x equal -4x plus 12. So let's graph this one and to find its one-to-one function or no, just by a graph. So if you want to graph it, you need 2 points. You can find the x-intercept or the y-intercept, because this is a linear equations. Or you can graph it using a calculator, it's fine, because the main thing we need to figure out it's one-to-one function or no. So by graphing, if you want to find the x-intercept and the y-intercept, let x equal 0, plug in 0 here, it's going to be -4 times 0 is going to be 0 plus 12 is going to be 12. Or let y equal 0. Where is the y? Here's the y. Always y equal -4x plus 12, because y is the same thing as of x. So the first thing, I'm going to let x equal 0 to get the y, then I'm going to let y equal 0 to get the x. So if I let y equal 0, here is going to be 0 equal -4x plus 12, and move this one here by adding 4x, by add 4x. So it's going to be 4x equal 12, divide by 4. So x is going to be equal to 3. So that's mean when y equals 0, x equal to 3. So I got 2 points from here. The first point 0, 12, and the second point is 3 and 0. Graph these 2 points to get the graph for this function. Then you will find, so let's graph it. I'm going to make simple graph. One, two, three, 4, 5, 6, 7, 8, 9.
Sir, and how can we get the x numbers? For example, if we get the y, put in the 0 in parentheses.
Okay. The first thing you're gonna let, remember when we trying to find the x-intercept and the y-intercept?
Yes.
So the first thing, you're gonna let x equal 0. Let's do it here. on this side. Let x equal 0. I'm gonna plug in 0 where? I'm gonna use this one, okay? I'm gonna plug in 0 here. So it's gonna be -4. Y is going to be equal -4 times 0 plus 12. So y is going to be -4 times 0 is going to be 0. So y equal what?
12.
That means 0, 12.
But how can we get the number of the x? For example, the 3. How can we get it?
Okay, so the second one, I'm going to let this steps here. You're gonna let y equal 0. Okay, you see, I'm gonna put y 0 instead of the y. Can you see here?
Yes.
Okay, so now solve this one. How are we going to solve this one? I'm going to move -4x to the other side, okay? So add 4x, add 4x. Cancel these. So what's the leftover from this side? 4x. What's the leftover from this side? Just the 12, okay?
Yes.
Then you're going to divide both sides by
4.
4. How much the x? 12 divided by 4 is going to be
3.
3.
So we're gonna do the equation by 0.
But yes. Oh yeah, instead of the y, you're gonna put 0.
And it's gonna be always by 0, or it's gonna be the number that is in the first?
No, always 0. Because the first thing, if you go back to section 2.3, I think,
Yes.
2.1, when we found the x-intercept and the y-intercept. Remember, to graph any linear equations, we have to find the x-intercept and the y-intercept.
Yes.
It is exactly the same thing. So now I'll just give you another method to find its one-to-one function or no by using the horizontal line test and the vertical line test. Now we got 2 points. Let's graph these 2 points. The first one, 0, 12, 0, 12 here. And the second one, 3, 0. 1, 2, 3, and the y is 0. You see, I got 2 points. So when I graph line between these 2 points, this is the line between these 2 points. Now I have the graph of the function. It's easier for me to graph a vertical line test and horizontal line test. So if I graph a vertical line test here to find it's a function or no, I will find at this x, how many y? 1 y. At this x, I found I have only 1 y. If you try to graph a vertical line test on this side, you will see for each x goes to 1 and only 1 y. Now the horizontal line test, so the first condition is satisfied, it's a function. The second thing we have to do, graphing a vertical horizontal line test. Graph any horizontal line test here. Let's do one here. So now check this. At this y, let's follow the line test to the graph. At this y, it goes to the graph, which is 1x. This line is not intersect with the graph in 2 points. It's intersect with the graph only on 1 point. That means at this y goes to 1x. So that means the second condition is satisfied. So it's one-to-one function. That's it for this example. Even if you're trying to graph it using the calculator, I'm going to show you that. And the function, the first thing you will see there is a graph here. Y equal. This is the first thing you have to do. and there's another column here that says graph. But first of all, you have to insert the function. So you're gonna press Y, write down the function, and the graph is going to be in the blue line. So write down the function here. Let's do our function, which is negative 4x plus 12. So I'm gonna say negative 4x, be careful, here's the negative sign here. Don't press minus, press the negative. Negative 4x, 4. How are you gonna write down the x? You'll see here it says x, t, theta, n. That means you can insert a letters, which is the x. So I'm gonna press this one. You see, negative 4x plus 12. Now I'm done. I already insert my function. The next step, I'm just going to press a graph, and you will see this is the graph of our function, which is just a line like this. So when I see this graph, I can then check if I graph a vertical line test, like here, I'm gonna find for each x goes to 1y. And if I graph a horizontal line test here, I'm gonna find each y goes back to 1x. That means in this case, I can figure out it's one-to-one function or no. Let's do another example, and also I'm going to show you using the graph. If we have f of x equal x squared minus 2x. You see this function is a quadratic function. So it's a quadratic function. How I'm gonna find which value I'm gonna plug in here? If you graph this one, let's graph this one first. And by seeing the graph, you will see it's a one-to-one function or no. So I'm just going to do exactly the same steps. Go here, press the y equal. You clear everything here and I plug in my new function. Here's the x squared minus 2x minus 2x. Now let's graph it. Now check this graph. I found that my graph like this. So this graph is not going to be one-to-one function. Let's see why. So let's graph it here. It's just a simple graph. I'm going to do it here. Then we got a graph like this. Let's see why it's not one-to-one function. So you see, I got this graph. Let's see why it's not one-to-one function. So I'm going to use the vertical line test and horizontal line test. Vertical line test, I'm going to graph a line test here. If you wanna, you can do one more line test, and you will see at this x goes to 1y. If you graph another line test, you will see exactly the same result. For each x, there is 1y. Let's check. That means the first condition is satisfied. It's a function. The second condition, let's graph a horizontal line test. I'm going to graph horizontal line test here. This is the horizontal line test. Then I will see at this y goes to how many x? I'm going to fill out the line test. This y goes, the first y here, and the second y here. That means I found 1y goes to 2 x's. Here's the first one, and here's the second one. I found y goes back to 2 x's. That means this is not one-to-one function.
Sir, the x's are the one in the shape of the quadratic or the vertical lines.
Yes, the quadratic,
Okay.
which is the x. There is the y coordinate. This is the y coordinate, and here's the x coordinate. So the y coordinate, when I'm telling you each y goes back to 1x, that's mean I'm talking about the x and the y coordinate, okay?
Okay.
So you have to pick points. You're gonna find if each x goes to 1y, which is a little bit hard for you. So to make everything easier, I told you, let's graph it. Let's do the same thing. Here's the calculator. I'm going to change this one. Clear. I'm gonna write down my new function. Parentheses 4x minus 9. Close the parentheses and put down the square. Graph it. Here's the graph, which is exactly the same the previous graph. So here's my graph. It's going to be like this. So I'm going to do a simple graph here. And here is my graph. It's like this on this side. Let's do it here. So now let's test this graph, the new graph. Let's graph 2 lines. 2 lines is going to be enough. Here is the first vertical line test. I'm going to graph it here. Vertical line test. You see, at this x, the x coordinate goes to 1y. If you graph another line test here, here's another line test. At this x, the x coordinate goes to 1y. That means each x here goes to 1y. So that's good. Each x goes to 1y. That means this is a function, which is the first condition. Now let's check the second condition by graphing horizontal line test. So I'm going to graph horizontal line test here. So this is the x coordinate. That's why I'm telling you each x on the x coordinate. This is the y coordinate. Now let's check each y coordinate goes to one point. So this is the y coordinate here on the line test goes, here's the first x and here's the second x. That's mean I found 1y goes back to how many x? 1, 2. Touch the graph in 2 locations. That means 1y goes back to 2 x's. So the second condition is not satisfied. So I'm just gonna say that means this is not one-to-one function. Why? Because I found this is the reason. Found 1y goes to 2 x's on the graph. That means it is not one-to-one function. Now to find the inverse of the function, you're just going to flip the points. For example, if you have f, the inverse, by the way, the inverse for the function is look like you're gonna always, the symbol for the inverse is like negative exponents -1. F to the -1. There is no -2, there is no -3. Every time when you see the function with -1, that means this is the inverse of f. So this is the inverse of f function. So if you have f like this, 1, 2, 4, 6, 3, -5. So this is the f. To find the inverse of f, here is the inverse of f, which is we're just going to flip the point. 2, 1, 6 and 4, -5 and 3. So this is the inverse of a function. We're just going to flip the points to get the inverse of the function. Even if you graph these points, you will get the graph of f. If you graph the inverse, you will get the graph of the inverse of the f. The graph of the inverse of the f. You will see that when we do an example. Another example, let's do g equal 5, -2, 0, 3, 4, and 1. This is the graph of, this is the f, sorry, the g. To find the inverse of g, this is the inverse of g. We're just going to flip the points, -2 and 5, 3 and 0, 1 and 4. This is the inverse of g. Graph f and the inverse of f. So here is f of x. They give you the function, which is 2x. Now we need to graph 2x. Then we need to find the inverse and then graph it. To graph any function, any linear function, we need at least 2 points. So let's choose 2 points here to graph the line. Choose 2 points here. I'm always choose negative and positive. So I'm going to choose -2 and 2. Here's the 2 points. Let's choose -2 and the 3. So you're not get confused. -2, I'm plugging -2 here. So 2 times -2 is going to be -4. This is the first y coordinate. 3, I'm going to plug in a 3 here. So it's going to be 2 times the 3 is going to be 6. So to graph f, I have 2 points. I have -4 and -2 and -4. And I have the second point, 3 and 6. So this is the graph of f. Let's graph it. Here is the coordinates. Let's graph the f function by using these 2 points. -2 and -4. 1, 2, -4, 1, 2, 3, 4. So here is the first point. 3, 6, 1, 2, 3, and 6. 1, 2, 3, 4, 5, 6. So here is the second point. So if I graph a line between these 2 points, it's going to be the graph of f. So here is the graph of f function. This is the graph of f function. Now I need to graph the inverse. The inverse of f. To graph the inverse of f, we're just going to flip these 2 points. So it's going to be -4 and -2. And flip the second point is going to be 6, 3. Now I'm going to graph these 2 points to get the inverse of f. The graph of the inverse of f. So the first point, -4, -2, -4, -1, -2, -3, -4, and -2 is going to be here. So here is the first point. 6, 3, 1, 2, 3, 4, 5, 6, and the 3, 1, 2, 3. So it's going to be here. So this is these 2 points for the inverse. Let's graph a line between these 2 points to get the graph, the inverse of f. You see, here is the inverse of f. So this is the inverse of f. First of all, we're going to graph this function, then we're going to graph the inverse. So I'm going to graph the table here, x, y. Let's choose 2 points. Let's choose -1 and 2. Or let's choose -2 and 2. Okay.
Sir, and the only homework you're gonna give is the numbers of the graph, or we're gonna put them in our
No,
own.
you have to put it. You have to choose. They're not gonna ask you to graph the points. They're just gonna ask you on the online assignment. It's going to be easier. They're gonna give you the graph, and you have to locate the inverse. Okay.
Okay, thank you.
But this one, in case if there is no graph, I don't think so. You're gonna get like this one on the online assignments. You're just gonna get the graph, and you have to grab the inverse. So I'm gonna choose these 2 points. -2, plug in -2 here is going to be -8. -8 plus 5 is going to be -3. That means here is the first point. So here is the points of f, -2 and -3. Plug in 2 here is going to be 8, because 2 cubed is going to be 2 times 2 times 2 is going to be 8. 8 plus 5 is going to be 13. So here is the second point, 2 and 13. When you graph these points, you're going to get the graph of f. -2 and -3, 1, 2, 1, 2, 3. So here's the first point. 2, 13. This is the 2. 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's going to be here. So you see, this is the graph of f. I'm just going to put line between these 2 points. Sometimes they're gonna give you the graph like this when you're doing the examples, and you just have to do the inverse, find the inverse. So it's gonna be the same. You're gonna take 2 points from the graph, write down the coordinate, then flip the points to get the inverse, the points for the inverse, and graph it. Now let's graph the inverse of f. Flip these 2 points, so it's going to be -3, -2, and it's going to be 13 and 2. Graph -3 and -2, -3, 1, 2, 3, and -2 is going to be here. 13 and 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 and 2 here. That means the graph of the inverse is going to be a line like this between these 2 points. This is, you can pass it through, this is the inverse. And this is f. So again, sometimes they're going to give you the graph of f, you just have to find the inverse. How to find the inverse? Take 2 points from the graph. Like if they give you this graph, take any 2 points from here, flip the points, graph it to get the graph of the inverse.